Right, welcome to lesson 1 of Unit 12. This is our last unit of the year, and we're going to talk about something called probability and statistics. Today, our title is for the fundamental accounting principle and permutations, and our goal is to use the fundamental accounting principle and permutations to count the number of ways an event can occur. The main thing, the title of this lesson, the fundamental accounting principle, basically says that you just multiply together the number of ways each choice can occur. This will make more sense once we get the context of an actual problem, but that is our big idea today, is the fundamental accounting principle. So, how many ways can you arrange the letters bad? So, in the first spot, how many choices do I have for the first letter? Okay, I can choose either getting a B, I could choose an A, or I could choose a D. I have 3 choices. Then from there, depending on what I choose, how many choices do I have? Let's say I chose B the first time. Then now I only have to choose A or D. Let's say I just misspelled and I chose D second, and now I just have A. Okay, so that is the idea here, is I go from having 3 choices to 2 choices to 1 choice. The fundamental accounting principle states that I must multiply those numbers together, and the total number of ways I should be able to arrange the letter bad, which should be 3 times 2 times 1, which is 6. Now, just since it's a small number, let's find out all those different permutations. I could have BAD, or I could have had BDA. I could have had, instead maybe I didn't choose B, let's say I chose A first. I could choose BD, or I could choose ADB. That's a second choice. Or I could have chosen the letter D first and have DAB or DBA. Those are the 6 different ways I could do it. Now, let's say at a restaurant you have a choice of 8 different entrees, 2 salads, 12 drinks, and 6 desserts. How many different dinners could you have if you choose 1 from each option? So, in the first choice you have, you need to choose an entree. I'm going to title that column E. And how many different entrees do I have? There are 8 to choose from. How many different salads do I have? That's the second thing I need. I need salads. And actually, I'll change colors here. I have 2 different salads to choose from. Then I have to choose a drink. And there are 12 of those to choose from. Then I have to choose dessert. And there are 6 of those. Now, the fundamental accounting principle states to figure out how many different combinations I have, I would have to multiply these numbers together. 8 times 2, that's 16. 12 times 6, that's 72. Now I have to multiply 16 times 72 together. 16 times 72, 2 times 6 is 12. 2 times 1 is 2, plus 1 is 3. 7 times 6 is 42. 7 times 1 plus 4 is 11. I have 1,152 different ways that I could order dinner. How many possible 7-digit phone numbers are possible if the first digit can't be 0 or 1? So we want 7 digits. Now, if you look at a phone pad, or even just a calculator looks kind of like a phone pad. What are the different numbers I could choose for in a phone number? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different numbers to choose from. However, the first digit cannot be 0 or 1. So I can't be 1, it can't be 0. So I have 1, 2, 3, 4, 5, 6, 7, 8 numbers to choose from in the first spot. But after that, you can use whatever digit you want, and there are 10 of them. So there are 10 in every number after that. All right, so a sample phone number might be 8675309. Okay, and you can repeat digits. You could have 5339. That's fine too. But the point of the matter is, you have 8 choices for the first digit and 10 choices for every after that. And the fundamental accounting principle states, I just multiply these numbers together to get my answer. Now it's going to get pretty large, so a calculator is helpful here. 10 times 10 times 10 times 10 times 10 times 10 has 1, 2, 3, 4, 5, 6 zeros. So that's actually 1 million. 8 times 1 million, because there's 6 zeros there. If you didn't know that, multiplying by 10, you just count how many zeros there are, and that's what your answer will be. 1 followed by that many zeros. So I guess I didn't really need a calculator for this one, but you can use a calculator to help make the fundamental counting principle easier. Isn't that crazy? You can have 8 million different 7-digit phone numbers provided that this spot can't be 0 or 1. Now imagine if you had the area code. You had a 701 here. You still have 10 choices for any of these. And in the country code, I think you have 10 choices as well. So then you could add 4 more zeros to that. You'd have 80 billion, actually I think 80 trillion different possible 10-digit phone numbers. So that's why there's about 9 billion people, 8 billion people in the world. That's why every single person in the world can have their own phone number. The next part of today's lesson is talking about the word factorial, which is the product of all the integers from 1 to n. Now, integers are just whole numbers. So, for example, -3, 5, 7, 102, those are all whole numbers. Now, again, product means you're multiplying, okay? You're multiplying all the numbers from 1 to that number. So I'm going to do 4 factorial first. I think that will illustrate my point the best. I'm going to multiply 1 times 2 times 3 times 4, all the way up to 4. If I had 7 factorial, it would be 1 times 2 times 3 times 4 times 5 times 6 times 7. And that's 7 factorial. Okay? Now 1 factorial is pretty easy. It's just 1. Now, the weird one in all this mix is going to be 0 factorial. That's the one that you should be worried about. Because if I multiply by 0, you'd think that this would be 0, but it's not. It's actually 1. And there's a big math reason why that I'm not going to get into because it's Algebra 1. But just trust me that 0 factorial is 1. And that's a very important idea to remember. 0 factorial doesn't follow the pattern. It's just 1. We learned about factorials because now we're going to talk about permutations, which is an ordering of objects. So basically, list all the orders of the letters X, Y, and Z. That's a permutation because order matters. So permutation, you can think of ordering or arranging. Order matters in permutation. That's the big idea I want you to come away with this. Permutation, order matters. The way I put X, Y, and Z together, the order matters because now you can see that they're different. If I put X and Y in different places, it makes a different arrangement. You can use the fundamental counting principle for ordering n objects. Now, in general, the number of permutations of n objects is n factorial, and that's it. The special cases, of course, are, like I told you, 0 factorial and 1 factorial. Consider a situation in which we don't want to order all the objects. Okay, let's write an ordering of 7 distinct objects 3 at a time. So I have 7 things. I'm just going to draw a picture of maybe like 7 different colors. So let's say I have pink, blue, green, red, orange, this greenish color, and maybe purple. All right, and actually I'm just going to change that because it looks too much like the other one. I'm going to make that black or gray. And now order matters on this one because if I put the colors in different order, it looks differently. But I want to group only 3 at a time. Well, we're going to use the basic counting principle for this one. How many choices do I have for the first color? 1, 2, 3, 4, 5, 6, 7 choices for the first color. How many choices do I have for the second color? Well, I picked one. Let's say I just pick one of these. I'm going to just pick red. Let's say I used red for the first one. Now how many choices do I have for the second color? Because I'm assuming I can't repeat using that red again. Well, now I only have 6, right? So let's say I chose, I don't know, pink for the second one. And finally, now that I've chosen all of those, now I only have 5 to choose from. And by the fundamental counting principle, I just multiply those together. 42 times 5, 210. 210 different ways to order those colors, provided that I can't repeat the colors and order matters. Okay, so there we go. I chose red, pink, and blue. But there are 210 different situations. And this can get pretty tedious, and that word just means complicated. I could just be multiplying forever if I had a large number of items. So there's a faster way to do this. This is called taking permutations of n objects r at a time. And so the way that I read this is n permutate r. You could also say n p r as well. Let me know. But if you have numbers, let's say that in this case, I had how many objects to choose from in this one? I had 1, 2, 3, 4, 5, 6, 7 objects. So it would be 7 permutated 3 at a time. So I want 7 of these. I have 7 of these colors to choose from, and I'm choosing groups of 3 at a time. Okay? And we found out that it was 210. Now the formula to do that, without having to just multiply 7 times 6 times 5 and all that other jazz, is given like this. You're permutating n objects r at a time, npr, n permute r. The formula is take this first number on top and take the factorial of that number and divide by the r, n minus r. So what did we do last time? Just to give you an example. I did 7 items, permutate 3 at a time. I had 7 colors. I wanted groups of 3 at a time. Then the formula would be 7 factorial divided by 7 minus 3 factorial. Okay? So that means I have 7 factorial divided by 4 factorial, which means I had 7 times 6 times 5 times 4 times 3. Oops, I'm running off the screen now. Let's do that down here. 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 7 factorial divided by 4 factorial, which is 4 times 3 times 2 times 1. Now, because I'm dividing, I can eliminate by dividing these common factors. It's like simplifying fractions and just dividing these out. And look at what I got. 7 times 6 times 5, that was the 210 I had from before. So here's another example just to drive the point home. Let's say there are 8 movies at the theater you want to see. How many different ways can you see all 8 of the movies? Well, there are 8 things to choose from, and order matters. We're going to assume that you don't want to, the ways you can see them, we're going to assume that order matters because they're different movies. And how many do I want to see? I want to see all 8. So this would be 8 permutate 8. So that means I would have 8 factorial divided by 8 minus 8 factorial. What's 8 minus 8? 0 factorial. You remember what 0 factorial was? It's 1. So I have 8 factorial over 1. So that means I have to erase all this stuff now. 8 factorial over 1, well, that's just 8 factorial. So 8 times 7 times 6 times 5 times 4. And this is the same as the counting principle. Now to get that, there's a factorial button on your actual calculator. And I don't have it on the screen right now, so I'll just do it by hand. But you will find out about the factorial button in class tomorrow. But I'm just going to do it all by hand. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. There are 40,320 ways to see all those movies. That's pretty crazy, isn't it? It's a lot of different ways to see the movies. Okay, now we're going to want to find out how many ways you can choose to see a movie this Saturday and 1 to see this Sunday. So I only want to see 1 on each of these days. Now on Saturday, let's just talk about Saturday. How many do I have to choose from if I haven't seen any of them? I have 8 movies to choose from, and how many do I want to see that day? Just 1. Now Sunday, I go to see another movie, but I've already watched 1, so how many are there left? 7, and I only want to see 1 on Sunday. So I have 7 permute 1 and 7 permute 1, which means that I have 8 factorial divided by 8 minus 1 factorial times, and that's Saturday. On Sunday, I have 7 factorial divided by 7 minus 1 factorial. So I have 8 factorial divided by 7 factorial times 7 factorial divided by 6 factorial. And just for the sake of time, I don't have a lot of time left in the video here, just know that I have 8 times 7 times 6 times 5 all the way to 1, divided by 7 times 6 times 5 all the way to 1. All those are going to cross out. I just have 8 times 7. So this is going to be 56 different ways. All right. So we'll talk about the repeating stuff tomorrow in class. I hope you have a great evening. I'll see you then.